We're now going to talk about digital to analog conversion, DACs. In the digital to analog conversion, you are providing a given digital information with a given precision, in that case 8 bits, and your DAC module will generate an output value using a full scale between the bottom reference and the top reference, in that case 0 and Vref. And in between Vref, it will generate Vout to be equal to the quantized version of this input. If we look at what we have here, so let's assume that the DAC uses an unsigned binary input code where Vout is in between V0 and Vref. Then, when the signal D is equal to 0, the V output should be equal to 0. If D is equal to 111, the V output should be Vref multiplied by 255 divided by 266, which is the full scale, and otherwise you get everything in between. So basically, in that kind of system, Vout is equal to Vref multiplied by D divided by the full resolution of your input. If we look at the output plot, that kind of system will basically create some sort of a staircase response depending on the input code and the output. So the output signal will increase in 1 LSB increments in that case. Following, again, the minimum resolution sample that you can get, which in that case would be 1 over the full resolution of your DAC multiplied by the reference voltage. So how do we perform a digital to analog conversion? Data in a binary digital format can be converted to analog using a summing amplifier. For example, let's consider a simple 4-bit digital to analog converter that can be made of 4 inputs, a 4-input summing amplifier. You have 2 basic approaches, which will be the weighted summing amplifier or the R2R network approach. Let's have a look at the very first one. Here is a summing amplifier. So you'll have an op-amp right here, with the output that you get here will be depending on the values that you find across those input resistors. Those input resistors are implemented as powers of 2s, and the input code right here will basically inject more current into the system that will in turn convert or generate an output value in between V minus and V plus. The other option is to use an R2R ladder, and the R2R ladder is again turning on or off those inputs be connected to ground or to Vref, the various input of the R2R ladder. And what is the effect of that is that the output value will depend on the digital code that you did put as the input to your ladder. The interest of a ladder is that it is much easier to match when implemented on a digital circuit because all the resistances are the same. It is just R or 2R, so if you just keep making resistances of an R value, you will be able to get a much better matching. This is different with the previous system where your resistances should be R, 2R, 4R, 8R, and so on and so forth. So you'll get a much harder matching and larger variability coming from that circuit. This circuit will be superior on that regard.